Okay, so now this last video is going to be the video solutions for the practice problem. So all the practice problems here, but I'm going to work them out on this paper. So once again, sorry for the echo. Okay, so the first problem. Let's zoom in. Okay, so the first problem states, given the reaction, here's my reaction, and it is balanced. It says how many moles, so we want to know the moles of H2O, and we're given 2.0 moles of Ca. So we always start with our given moles, and then we're going to multiply it by a mole ratio. And so we do the moles that they're asking for, the moles of H2O over the moles of Ca. So remember, the coefficients, the little numbers in front, tell us the ratio of moles. And that ratio is fixed and it does not change. So based on my equation, I have 2 moles of H2O for every 1 mole of Ca2. So I cancel out just the moles of calcium, not the numbers. So I do 2 times 2 divided by 1 is going to give me 4.0 moles of H2O. And that's going to be answer choice D. So there's another way of doing this too. So when we sub fractions, they have to equal each other. So in the problem, I was given 2.0 moles of Ca, and I'm looking for X amount of moles of H2O, and that's to be equal, because again, it's a fixed ratio. I'm sorry, let me move that over. And so by my equation I have 1 mole of Ca. Again, so here's my Ca. No, if there's no letter, it's just 1 over 2 moles of H2O. So I'm going to cross multiply. I'm going to do 2 times 2, which is going to be 4. I'm going to divide it by 1 to find X. That was a really long one. I don't know why I put X in so many places. And that's going to equal 4.0 moles of H2O. Here's just another way of doing this, setting up that same problem. But for now, I'm going to just keep it in this. So refer back to this if you prefer it better, especially if you do a lot of cross multiplying in math, and you just find it easier to set up this way. Feel free to do that. Doesn't matter how you do it. Well, it doesn't matter how. That doesn't make sense. Okay. Next problem says, in the reaction, N2 plus 3 hydrogen is going to give me 2 ammonia. So I know this is ammonia. If I refer to table E on page 2 of my reference table, let me take out a reference table. So here's my reference table. I would zoom out, but then I would go zoom out again, so I'm not going to. So we find table E with our pi atomic ions. So if we look, ammonium is NH4, ammonia, and the Ia is going to be equal to NH3. You must memorize that ammonia is NH3, because you'll see it a lot. Eventually you can use it. So that's ammonia, NH3. Okay, my equation is balanced. So okay, so it says how many grams of H2 to produce 1 mole of ammonia. So I have my 1 mole of ammonia. I gotta set up my ratio. I'm looking for my moles of H2. I always put that at the top, and my moles of NH3 at the bottom. Because I want to end up crossing that out to get moles of H2. So I look at my formula, how many moles of H2 do I have? 3, because there's a coefficient 3 in front. And then I look for moles of NH3. I know that's 2 because that's the coefficient 2 in front of my NH3. I do my math. I do 1 times 3 divided by 2. 1 times 3. So 3 divided by 2 is going to equal to 1.5. So, and I know I have 1.5 moles of H2, but remember they asked for grams. They want grams. Okay, and now so I'm gonna convert my moles to grams. So remember, 1 mole of an element or a compound is the mass. So if I say I have 1 mole of carbon, that means I have 12 grams of carbon. So when I have 1 mole of H2 is the gram formula mass. So the mass, I'm just gonna go through here. My mass of H2. So I'm gonna go on my periodic table in my reference sheet. Get that out, and I'm gonna look up my element. So this number at the top is my mass. Okay, my mass. So I'm gonna put that closer. So you can see it's about 1.007, so I'm going to round that to 1. So to find my mass, I take my hydrogen, right? There's 2 of them times 1 for my mass. There's 2 hydrogens times 1 for my mass, and then I have 2 grams. Okay. So I know that my mass is going to be 2 grams. My moles cancel out. And I'm going to have 1.5 times 2 is going to give me a total of 3.0 grams of H2, and that's going to be answer choice B. So guys, I'm going to split this video up. As you see, I'm recording at school. You're welcome, people who are so very rude in class. Okay, question number 3. Sorry, this is going to be a very long video because there's a lot of explaining. So given the reaction, 2 sodium hydroxide plus sulfuric acid is going to give sodium sulfate and 2 H2O. So they're asking for the total number of moles of NaOH if I'm giving 2 moles of sulfuric acid. Okay, so we always start with given. We have 2 moles of H2SO4. I'm going to multiply that. I'm going to put the moles of H2SO4 at the bottom over the moles of NaOH at the top. So how many moles of NaOH do I have? I have 2, right? 2. How many moles of H2SO4 I have? For H2SO4, I have 1. So I'm going to just multiply 2 times 2. So it's going to give me 4 moles. Let's go to that. Moles of NaOH. And that's D. Okay. Number 3. Oopsies. So it says, given this formula, this reaction, how many moles of Al2, that's the moles I'm looking for, is going to form 27 grams of aluminum to react with O2, when complete react with O2. Okay, so we're given aluminum, right? So you gave me 27 grams of aluminum. So this react with O2 is just telling me what's happening in the equation. I don't have to pay attention to it. Just look for the information that you're given and that you need. They give you a lot of information you don't need on these. So I have, so if we look at the rest of our problems, we see that we were given moles. We did everything in starting with moles. But this time they gave us grams. So, but we need it in moles. So we're gonna convert our aluminum, our grams of aluminum. Sorry if my screen keeps going out. Grams of aluminum. Hold on.
Ariana Watson, please report.
Okay, so we're converting grams to moles. So again, so our grams are going to be in the bottom, so you cross out, and remember it's just the mass of AL. So I'm going to go back to my reference table. I'm going to open it up to page 9. I'm going to look for aluminum. And aluminum is a 13. I'll hold it up close. And we're going to see that our mass is 27. Aluminum, so it's 27 grams for every 1 mole. Okay, take my calculator. Clear that. I'm going to divide, oh, I wrote aluminum. So sorry, guys. 27. Holy crap, is that 1 to 1? Hold on. I'm just checking my mass of my aluminum. I have 27 grams. Oh, okay, cool. So I have 27 grams and there's 1 mole. So 27 is going to come out to be 1 mole. So in class, someone told me it was 24, so I should always check. 24 moles of aluminum. I cross across, so 27 divided by 27 is 1. So 1 mole of aluminum. Just gonna and put 27. Okay, 27 times 27. So my grams are gonna cross out. Okay, so now this is starting. So now we have to do our mole conversion. So we want moles of AL 203 over moles of AL. So we can go back to our equation. Our moles of AL is 4. Our moles of AL2 is 2. So I'm going to do 1 times 2 is going to equal 2. Divide that by 4 is going to give me 2. Okay, I'm just going to check that. Okay, ooh, I made a boo-boo in class. I don't know why I thought, yeah, I thought they gave me 27 grams of oxygen. Oh well, now you know the answer. Okay, same work, doesn't matter. Okay, so now this next question, they gave an equation. I have, they're asking for the total number of grams of Mg, and they gave me 0.5 moles of H2. So I got 0.5 moles of H2. I'm going to multiply that by that ratio. So they wanted to know the grams, but we have to find that later. So we know the moles. We know moles of H2 over moles of H2. Mg, sorry, H2. So Mg has 1 mole, and my H2 also has 1 mole. So we end up with 0.5 moles of Mg. So you could say this is a calculator, guys, but so 1 divided by 1, anything divided by 1 is that number. So if I have 7 divided by 1 is 1. Same thing as multiplying. 6 times 1 is 1. 5 times 1 is 1. 0.62345 times 1 is 0.62345. Got it? Hopefully you got it. Good. So again, we found the moles of H2O for this reaction, right? But again, they asked for grams. And our answers are in grams. So now we have to convert. So this equation at the top, I put my moles on the top because I started with my grams. And I put my grams at the bottom so I could cross out and end in moles. This time I had moles, but I want to go to grams, so I'm going to put my moles on the bottom. So 1 mole times my mass of Mg. So if we look at Mg at the bottom, it's 24 grams. 24 grams. So my moles cross out. I do 0.5 times 24. that's going to give me 12 grams. Answer being B. Okay, and the last one, last mole the mole, not last one, but last mole the mole. Let's try to finish it before 5th period, and then continue during 8th. Okay, so we have this reaction. They're asking for what's the total number of grams of O2 need to react with 0.5 moles of C2H4. So we have 0.5 moles of C2H2. I'm going to multiply that by what we're looking for in moles of O2 over the moles of C2H2. I'm thinking of, oh yeah, okay, now we're going to find the moles. So the moles of our oxygen is 5 because that's the coefficient in front. And moles of our C2 is going to be 2 because that's the coefficient in front. So I'm doing 0.5 times 2. So I'm going to put that in my calculator. Should I get that in frame? 0.5 times 2. Because I could do this in my head, but some people need, and then divide that by 2. Divide that by 2, and I get 0.5. Oh wait. Oh yeah, we're good. Oh, I said 0.5 times 2. 0.5 times fab. I mean, that doesn't make sense. Is 2.5. Times 5 is 2.5. And then divide that by 2. Is going to give me 1.25. 1.25 moles of O2. Remember, once again, they asked for the grams. So I got to do, so I'm going to put it over here, 1.25 moles of O2. And multiply that by 1 mole over the mass. So oxygen, the mass is 16, but there's 2 of them, making that 32. 32. So multiply that by 32 grams. So my moles are going to cancel out. Stop it! And that's going to give me an answer of 40 grams. I make my answer B. I know, a lot of work, right? Okay, we're going to do this one last problem. The freshmen are kind of annoying me, so whatever. So this is a percent composition. So remember, we always do the mass of the element over the total mass times 100. So this is asking for the mass of oxygen. Okay? So first we gotta find that total mass. So we do our formula mass. We have mg, there's 1. Oxygen, there's 1. And then multiply this by my mg. My mg is 24. Multiply that by 24. Times 16 to get 16. 16 plus 24 is going to give me 40. So that's my total mass. So 40 over the mass of just my oxygen, which is 16. And multiply that by 100. So clear, I'm going to do 16. 16, divide that by 40. And times 100 is going to give me 40%. Okay, so that's solutions for 1 to 7. Okay, take a screenshot. Yeah, I'll pause the video. Okay, I will see you during the 8th period. And bye-bye.